I'm waiting for my classmates. Alright, I'm not going to wait any longer because, well, I'm not going to waste time, and the first few questions are easy anyway. So, today we're going to go through the O-level A-Maths paper from 2019, paper 1. It's a very easy paper, honestly. If you didn't pass this paper, I don't know what to say to you. So, I'm assuming that all of you have the questions already. If you're at my class, you would have received my distribution of the questions because you guys don't have your TYS like that. Otherwise, if you're watching this and you don't have the questions, well, I'll leave a link to them later. So, let's start with the question 1. Now, I'm not going to write the questions on the board, that will waste time. If you have already received the questions, then you will know, what they are. So I'll just read them. Given that theta is a Q and cosine theta is equal to C, express in terms of C, tangent theta and cosecant theta. So let's start with tangent theta. So we know that cosine theta is equal to C and theta is less than 90 degrees because it's acute. So now we know that cosine theta is equal to C, right? So what is tangent theta? Okay, think about it. Tangent theta is equal to sine theta over cosine theta. Tangent theta is equal to sine theta over cosine theta. But we know that cosine theta is just C. Okay? Then what is sine theta in terms of C? Let's use this identity. Sine square theta plus cosine square theta equals to 1. We'll use this identity. Okay? If you don't know this identity, then what are you doing? It's literally in the TYS. It's literally in any exam that you take. Okay, so let's now put sine square x as the subject. Sine square theta is equal to 1 minus cosine square theta. Well, what can we do now? We will take the square root on both sides, right? So sine theta is equal to the square root of 1 minus cosine square theta. And we will only consider the principal value of the angle because we are looking at the acute angle, i.e. we will only take the positive. We will not consider the negative version of this. So we can say that tangent theta is equal to, and finally, square root of 1 minus cosine square theta all over, which is all over C, right? But we know that cosine theta is C, so this is 1 minus C squared all over C. Yeah, that's your 4 marks. 3 marks, sorry. You will get your 4th mark from when you do the cosecant theta. So cosecant theta is just 1 over sine, and we know that sine is this thing. So we have cosecant theta is equal to 1 over the square root of 1 minus C squared. And yeah, that's it. We don't need to rationalize this according to the answer key that we were provided over here. Question 1, no problem, right? I'm sure you all should get 4 marks on this. Question 2. Find the set of values of the constant k for which the curve y equals to x squared plus 2k plus 1 x plus 1 lies entirely above the line y equals to x. Okay, so we just need to equate this, right? So we will have x squared plus 2kx plus 1 equals to 0. Equals to 0? Are you sure it's equals to 0? Remember, the curve lies completely above the line, which means that this is more than 0. Okay? So, if this is more than 0, what does it mean? It means b squared is less than 4ac. So, 4k squared is less than 4, because this 1 is 1. Okay, what can we do now? K squared is less than 1. Square both sides. This time we do need to consider plus minus. So, k is less than 1 or k is greater than negative 1. Combine the two inequalities. Negative 1 less than k less than 1. I don't know what to say to you if you do not get this question right, because this is 4 marks. Look, this is a question that should really be worth like maybe 2 marks, but it's 4. I hope you guys understand here what I'm trying to tell you, because this is not a difficult question at all. The first few questions are really not that difficult. We will now move on to question 3. This one looks a bit trickier, but it actually isn't. Given that y is equal to a e to the power of 2x plus b e to the power of negative x, and that dy dx plus 4y is equal to e to the power of 2x minus e to the power of negative x, find the value of each of the constants a and b. So let me just write that down here. So what we know is that y is equal to a e 2x plus b e negative x. Okay, so we need to find dy dx because we have an identity given to us that involves it. So what's dy dx? Okay, so remember, when you differentiate e to the power of x, the easiest thing ever is just e to the power of x. And when you have e to the power of ax plus b, you will get a times e to the power of ax plus b. So this will be 2ae to the power of 2x plus, this is a minus however, so we might as well write a minus, right? b e to the power of negative x. So this is our dy dx. Correct? Now we will have to find dy dx plus 4y in terms of x. 4 times of this, so this will be equal to 2ae 2x minus be minus x plus 4ae 2x plus 4be minus x. Right? So this whole thing, we will simplify this now. These are the same, so we can add them. 6ae to the power of 2x plus 3be to the power of negative x. And from the question, we know this is equal to e to the power of 2x minus e to the power of negative x, right? This is what's given in the question. Because of this, we now need to say that 6a is equal to 1, 3b is equal to negative 1, which means that a is equal to 1/6 and b is equal to negative 1/3. Another easy 4 marks. Do we have any questions thus far? I don't think so. We will move on to question 4. You guys are really not missing out on too much even if you join late, because these few questions are easy. Question 4 is also easy, and it's also 4 marks. The first 4 questions in this exam are all 4 marks. Well, that's paper 1 for you. Question 4. An ice cube of side x cm is melting in such a way that the total surface area, a square centimeters, is decreasing at a constant rate of 48 square centimeters per second. Assuming that the cube retains its shape, calculate the rate of change of x when x equals to 10. Okay, so first we must find the expression for the area, which is just 6x squared, right? So a is equal to 6x squared because there are 6 sides on the cube and each side has an area of x squared because x is the side length of the cube. Okay, so we know from the question dA dx, no sorry we don't know but we can figure it out ourselves. This is just 12x, right? What we do know from the question is dA dt is minus 48, right? What do we want? We want dx dt. So dx dt, this is equal to dA dt divided by dA dx. Because we want to cancel out the dA's, right? So we have dA over dt times dx over dA, and that's dx dt. But this is the reciprocal of that, so we might as well just divide, right? So this will become negative 4 over x. And when x equals to 10, dx dt is equal to negative 0.4 cm per second. Done. Another 4 marks. You should have 16 marks to your record at this point. The next question is a logarithmic word problem, and 6 marks. You should be able to get all 6 because it's equation. So the first part's a bit long. You have to listen carefully if you don't have the question. A manufacturer produces a disinfectant that destroys 21% of all known germs within 1 minute of use. If N, capital N, is the number of germs present when the disinfectant is first used, and assuming germs continue to be destroyed at the same rate, explain why the number of germs expected to be alive after small n minutes is given by 0.79 to the power of small n times big N. Okay, so we know that it will destroy 21% of germs per minute, so we can say that the number of germs alive after a minute is given by 1 minus 0.21 equals to 0.79. So 1 out of 1 of the germs, so 100% will be alive when it's first used, right? So at 1 minute it will be 0.79 or 79%. So we know that at 1 minute, (0.79) times n germs will be alive, because we know that this is 79%, right? So 79% of n will be alive because 21% are destroyed in that minute. What we have to consider next is that in the next minute, 21% of the remainder will be destroyed. So equals to 2, then you have 0.79 squared n. And what we know is that, let's say that from 0 to 1, if you have x between 0 and 1, square it, it will be valued, x squared will be smaller than x. So this will be smaller, which means that more germs will be gone, right? Okay. So if we equate this to n, where n is minutes, 0.79 nn. This is the formula that is derived. Because to derive the first step of the formula, we just need to have 0.79 times n. You can put a power 1 here if you want. So this is just a normal explanation using mathematics. You don't really need to go too far into this. So this is no problem because you understand the problem anyway, the question. The manufacturer decides to advertise by stating that the disinfectant destroys X% of all known germs within 20 minutes of use. Calculate the two significant figures, the value of X. This is a very simple formula. 1 minus 0.79 to the power of 20, because what happens is that 0.79 to the power of 20 is a very small number, so that will tell you that it is a small percentage of germs that are left. So you have 1 minus this, and then you'll multiply by 100%. This is Emacs kind of thing. So I'm not going to calculate this, but the answer, because it says two significant figures, will be 99%. Okay, this should be quite simple. I don't think anybody will have problems with this one. Last part. Given that the number of germs expected to be alive after n minutes can be expressed as capital N e to the power of k small n, find the value of the constant k. Okay, I'll write this up. We know that n e k n plus 0.79 n is equal to just n. This is what we know. Because this is the number of germs that have been killed. This is the number of germs that are alive. So what we know is that this is the total number of germs, okay? What we need to do now is we need to divide by n on both sides. So e to the power of kn, there's a plus 0.79 to the power of n. Now there's a capital N on all sides, so we can just divide here, no problem, it goes to 1. Okay? So what now? Okay, what if we take ln on both sides? Ln on both sides, ln e to the power of kn, this will just be kn plus ln 0.79 to the power of n, but we can just put n here instead. This will be equal to ln 1, which is 0. That's to say that negative kn is equal to n ln 0.79, correct? So now, you just divide by n on both sides and then polarize them. K will be equal to negative ln 0.79. This is the exact answer. And k should be, and you would think that k is a positive number, and it is, because ln e is equal to 1. So when you have a number when you have a number that's smaller than 1, you know that ln 1 is equal to 0, so anything smaller than 1 but more than 0, it will become negative, which means that this will cancel out and it will become positive. Okay? Now we go on to question 6. Question 6 is a proving question, or proofs and proving geometry question. I will need to draw this out on the board for you to visualize this. So give me 1 minute, guys. Let me see. You have a circle, O. This is Q. This is P. And QP is a diameter. QP is a diameter. Okay? There's a tangent to the circle here. Let's assume that this is like a tangent. So this will be point T. This is a tangent. Then it extends to here, S. Then this line goes through, and this is R. And then QR connects. It connects like, this is quite hard to draw. Don't worry about that. There you go. This is point T. There's R, there's S. I think there's one more line going down here from T to P. Okay. Yeah, and then extend this. Okay, this is something like the diagram. I have this diagram better plotted in decimals and I sent it to you guys. So if you don't have it, then just try and make do with this. So let me read the question for you. In the diagram, PQ is the diameter of a circle centered O. You can see that. Triangle PQR is an isosceles triangle with PQ equals to PR. So let's do this. The line QR intersects the circle at T, okay? And the tangent to the circle at T meets PR at S. So first we need to show that the angle of TSR is equal to 90 degrees. We need to show that this here, TSR, this we need to show it's a right angle. Okay, so we can't really do this using immense techniques, but what I will do for you guys is that let's start by thinking about the TO. TO is a radius of the circle, right? So this is not given in the question, so I'll draw this as a dotted line. Okay, what do we know about TO? It's a radius, and T is the point at which the tangent touches the circle. So we can say that this here is a right angle, and because this is a straight line, we can also say this is a right angle. tangent is perpendicular to the radius, if you write that down. So, I'll write that down if you want. QTP is equal to RTP is equal to 90 degrees because tangent is perpendicular to radius. Okay, then what now? So, what you might have noticed from the diagram is that TO is parallel to RP. But how do we prove that? Now this uses an AMATS technique called the midpoint theorem. Let me just subtract and draw a triangle for you guys. Let's say that this is triangle A, B, and C. Okay? The midpoint here of AB, I'll call it M. The midpoint of BC, I'll call it N. These are midpoints. If I connect these points, you'll notice that there's a common angle here. You have this common angle, ABC or MBN, of these two triangles, and the ratios of these are the same, right? Because AM equals to MB and BN is equal to NC, so MB is equal to 2. Okay. So 2MB is equal to AB and 2BN is equal to BC. So since we have two sides with similar ratios and the common angle, we can say that triangle ABC and triangle MBN similar. I won't write the reason, but there's one common angle, ratios of the sides are the same. So they are similar, and because they are similar, we will know that this angle and this angle are equal, this angle and this angle are also equal. So what does this mean? What does this look like to you? If these angles are equal, like this, they are corresponding angles. So we need to say, by the converse of corresponding angles, these two are parallel. That is why we can prove that over here, we know that, we can prove this in a minute. Okay, so QT, TR, we first need to prove that, well, T is the midpoint of QR. We already know that O is the midpoint of QP, because it's the center of circle and the diameter passes through it. So, how do we prove this? Simple. See, right, if I extend this, what we need to take into account is that since this is perpendicular as well, we can say that this whole line here is a perpendicular bisector. This line is a perpendicular bisector because this angle and this angle are equal. Well, this side and this side are equal. So we have already proven that QTP and RTP are congruent. And that's why we have this anyway. So we know this perpendicular bisector, we know that QT equals to TR, so T is a midpoint. So we can say, I know this is quite a lengthy explanation, but we can say that TO is parallel to RP due to the midpoint theorem. I did not write a reason for that, but you just bear with me. Now because of that, how's that useful to us? See, if we know these are parallel, then this is a right angle, right? This means that this is also a right angle. And PR is a straight line. So adjacent angles on straight line, this is a right angle. Done. I did not write down the reasons for these, but if you understood the explanation, then I think that is good enough for now. Because this is actually a question about proofs in plane geometry, but it might not be tested. Because you guys haven't learned it yet, but I thought it would be nice to go through anyway. So this AMATS technique called the midpoint theorem. This is one of the things you were supposed to learn about the proofs in plane geometry. But because of this COVID-19 situation, it's possible that we might not learn that chapter at all. It really depends. Okay? So now the second part is something that you should be able to do. Explain why the circle passing through the points SR and T has the center at the midpoint TR. Okay, so let's remember that this is the 3 points that we are talking about. So let's say that we draw the circle. If I draw a circle passing through these 3 points, just ignore the fact that it's not really a circle. I'll draw it again, I guess. So let's say that it's something like this. It's hard to draw. But you will see that, what you know is that any angle in a semicircle is 90 degrees. And that is what we literally just proved. So, what does this mean? It means that by the converse of a right angle in a semicircle, this over here, this whole thing is a circle passing through TR and S. That means that the circle has a diameter of TR because it's the longer side of this right angle triangle. And if the diameter is TR, then what is the center? It's the midpoint of these. This is the center. So let's say this O1, O2. Okay, this is Emaths. I think you can prove that yourself. Question 6 is just a question about first and geometry. Question 7 is binomial theorem. Write down and simplify the first three terms of the expansion in ascending powers of x of 2 minus x over 8 all raised to 6. So let me write that again. Okay, binomial theorem. Let's get started on this. So this is equal to, we don't need to write the first coefficient because that's just 1. So we have 2 to the power of 6. Okay, but this is a minus, so let's just minus here. Then this will be 6 choose 1. 2 to the power of 5 x over 8 1 plus, because this will be positive now, so 6 choose 2. 2 to the power of 4 x over 8 to the power of 2, and we can plus dot 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 here because we only need the first three terms. Okay, so now let's simplify. 6 choose 1 is 6. This is 32. This cancels out, so this is 4. So this will be 24x. Sorry, this will be 32 plus that. You cannot forget this. 64 plus 24x. Okay? Actually, it's minus. Oh my god. I'll start again. So this is 64. So this is equal to 64. This 6 choose 1 just 6. 2 to the power of 5 is 32. This cancels out with the 8, becomes 4. So you will have 24, but there's a minus here. So 64 minus 24x. Okay, 6 choose 2 is 15. So 15 times 16, then this cancels out. This will become 2. The 16 is 8. This will become, yeah, this will become 2. But actually this is squared. So this will be 64. So this 16 is 64, this will become quarter. So actually this is 15 over 4x squared plus dot dot dot. And this is the binomial expansion. Because what happens is that when you have x over 8 squared, this becomes 64. So when you cancel, it becomes, this will become 1 over 4. So you have x over 4 times 15. Okay? That is the binomial expansion. I hope you guys got that. If you didn't, then I'll give you a minute. So 64 minus 24x plus 15 over 4 x squared plus dot dot dot. We only need the first three terms. In the expansion of 4 plus kx plus x squared times 2 minus x over 8 to the power of 6, the sum of the coefficients of x and x squared is 0. Find the value of the constant k. Okay, so let me write that again. So 4 plus kx, sorry, plus x squared, 2 minus x over 8 to the power of 6. Okay, so we can actually change this over here to, because we have the first three terms of the expansion, we'll just change this to the 64 minus 24x plus 15 over 4x squared plus dot dot dot. And we are only concerned with the first three terms because we only need the coefficients of x and x squared. We don't need to worry about everything else over here. So let's say the coefficient of x, I'm just going to write coef x. What is this? Coefficient of x. So what do we need to consider? We need to consider 64 times kx and 24 minus 24x times 4. So this will be, let's say, negative 96 plus 64k. We're going to keep this on our mind for a bit because we need to find the coefficient of x squared as well. Okay? How do we find this? We need to multiply this, multiply this. So this will be 15. Then you have 15 minus 24k plus 64, right? Now if we add these together, this will be equal to 0. That's what we are given in the question. Remember that coef x plus coef x squared equals to 0. So let's add 9. So let's deal with this. So let's add them. So we will have plus 96 here. So I'll just convert this accordingly. We'll start by converting this. So this will just be 79 minus 24k, so we can have an easier time dealing with this. So if I just add these together, you'll have 40k minus 17 equals to 0. Yeah. So k is equal to 17 over 14. Okay. That is question 7, part 2, done. How are you guys holding up? Oh, you're doing binomials, That's nice. Wait, Arda, I thought you were IB. Question 8. The equation of a curve is y equals to x plus 2x plus 5 over x minus 2. So y equals to x plus 2x plus 5 over x minus 2. Okay, find dy dx and d squared y over dx squared. This is easy. dy dx is equal to, this is just 1, right? 1 plus, okay. Now we need to do our division, our quotient rule. So we will have x minus 2 du dx, so this is just 2. No, not plus. Minus 2x plus 5, let's just go to 1, then all over x minus 2 squared. Hopefully you guys can see that. I'll say it again. dy dx is 1 plus x minus 2 times 2 minus 2x plus 5 times 1 all over x minus 2 squared. We can simplify this to 1 plus, sorry, we can actually simplify this. So let's say I'll actually expand it. So this will be 2x minus 4, this will be 2x minus 2x plus 5, but the 2x cancels out, so it will become minus 4 minus 5 minus 9. So minus 9 over x minus 2 squared. This is dy dx. Can we do that? I'll explain that again. So if I expand this will be 2x minus 4 minus 2x plus 5. And 2x cancels out, minus 4 will minus 5, so we have minus 9. Okay? D squared y over dx squared is also quite easy. This becomes 0, so now we just need to do this, right? Okay, so, but first of all, we can write this as 1 minus 9x minus 2 all to the power of negative 2, right? So this will help us eat later. So this is just equal to 0. Then we can deal with this separately. So this will be minus 9 times negative 2, right? We bring down the power. X minus 2 all raised to negative 3. And then we multiply by the d dx of this, which is just 1. Okay? Then we will simplify this. This is going to be just minus 18, right? So this whole thing will be equal to minus 18 over x minus 2 all raised to power 3. You should get this for your d squared y over dx squared. Yeah. Okay. Now we can do part B. Find the x-coordinate of each of the stationary points of the curve. Okay. So what happens is that now that we have our dy dx, okay, I'll remove my d squared y over dx for a minute. So I'll rewrite these because we just need the workings for those just now, but now we just need the actual values of them. We don't need to work them out again. So let's say that we have, so reminder that dy dx is equal to 1 minus 9 over x minus 2 squared. Okay? So we want the stationary points, which means that we need dy dx equals to 0. So let dy dx equals to 0, then we know that this is equal to 1, right? So we can say that x minus 2 squared is equal to 9, correct? And you can actually solve this in your head. X is equal to 5 or x equals to negative 1. So these are the x coordinates of the stationary points. We don't need to find the actual points. Now we can find the nature of each stationary point. I will use this side of the board. This is where our d square y over dx squared comes in. I'll a bit. D square y over dx squared. We know that this is equal to 18 over x minus 2 all raised to 3, right? 18 over x minus 2 all raised to 3. Now we will substitute our values of x. So sub x equals to 5. D square y over dx squared equals to, this is 5, then it's 2, so this is 18 over 27. So we don't really need to work it out, but this is 2/3. And we know for sure that this is more than 0. Because this is more than 0, the stationary point at x equals to 5 is a minimum. Because when you have d square y over dx squared is more than 0, it's a minimum point. If it's less than 0, it is a maximum point. Okay, you obviously cannot use this for inflection. You need to do first derivative test for that. So now we will do the next one, which is x equals to negative 1. So at x equals to negative 1, d square y over dx squared is equal to 18 over minus 1. So this thing is minus 2/3, correct? Okay? Then therefore, stationary point at x equals to negative 1 is a maximum point. Okay? This, see? I think the only tricky question so far was the question 6 with the proving that we have not done before. Everything else is quite manageable, right? Question 9 is another question involving chord geometry. So listen up. The diagram shows a kite ABCD. I will need to draw the diagram, but luckily it's easier to draw another one. Okay, so this is O. So let's say this is A, B is down here. Okay. C, and the point is all the way up here. This is point D. Draw down. Okay, AC. So this is actually intersecting at the same point. Just pretend they are at the same point. Oh my god. That's so weird. I'll draw this again. So let's see if they cross here. Okay. So just pretend that this is a kite, okay? So the diagram shows a kite ABCD in which AB is equal to BC, let's write that, and AD equals to DC. Okay? The points A, 0, 2, so this is 0, 2, and B lie on the y-axis. Diagonals AC and BD intersect at the point P on the x-axis, so it's here. So given that the length of AB is 4 units, explain why BC is parallel to the x-axis. Okay, so let's start by saying that angle BAC is common. So first I want to prove that. So first I want to prove that this is a. So you see that they will be right angles, right? So let's prove that. So we know that this is a perpendicular bisector as well. So yeah, and then this x is also going to be a perpendicular bisector. well, not perpendicular bisector, angle bisector. And why is that so? AO equals to OB, so this angle bisector, this is 45 degrees, 45 degrees. You can see where this is going, right? So we know that, so we want to prove this. So here is 45 degrees. Now what we see is that this is a common angle, then ratios are the same because these are both, because x-axis is perpendicular bisector to this, we can prove that because this is 2, and this is 2, and this is 4, so this is also 2, so this must be a bisector. And then this is also a bisector. So that means that we know that these two triangles are similar. AOP, ABC, they are similar, which means that this is also 45 degrees. And by the converse of, once again, converse of corresponding angles, this is parallel. That's just 2 marks though, so I won't be writing too much into detail, but you get it, right? Find the coordinates of C. This is easy. After all, you already know AB equals to BC, and you know that this is parallel to the x-axis, so it will only increase by x. So this is 4, this must also be 4, so this is just C is equal to 4, negative 2, because this must be 0, negative 2, right? And this is 4, negative 2. So let's write that down here. Okay. Given further that the area of the kite is 28 square units, find the coordinates of D. Okay, give me a second, yeah. Everybody okay so far? Now how do I do this? D is equal to... I know what the answer is, but how do I get to it again? Let me see. Okay, so let's let the coordinates be let's let the x coordinate be h then. So this will be 4, but how do we find this? So we know that these lengths are equal, so this is not what before. Never mind, I'll solve it my way. So we need to realize that this is a 45-degree angle, so this is actually an equation. BD is actually the equation y equals to x minus 2, okay? So let's use that, and that is to say that if we plus 2, then the coordinates, if D, we increase the y coordinate by 2, then we will know that the coordinates are the same. X and y coordinates will be the same. So let's let D equals to hk. Then we know that, from here we know that kh is equal to k plus 2. Correct? H is equal to k plus 2. So, this is quite a good question for me. Now we can use our area formula. So let's use the area formula. I'm not going to work it out fully, but you know what the procedure is. 0, 2, 0 minus 2, 4 minus 2, h, k, 0, 2. Luckily there's a lot of zeros in here. Now I'm not going to work this out in full detail, but you will get this whole thing is equal to 28, right? So you will get k plus h plus 2 equals to 14. This is what you will get from the area formula. I will not work it out. But k plus h equals to 12. So now we can solve simultaneously, right? So this is k plus 2 is equal to 12. So k equals to 5, h equals to 7. So this here is d is equal to, so this is the final answer, d is equal to 7, 5. Final answer. This is a bit tricky for me to explain, but hopefully you get where I'm coming from. You need to realize that BD has the equation y equals to x minus 2. Okay? So this is your area if you work it out. Anyway, area will only be worth 2 marks in itself, even if they ask you for the area. So this 5 marks is, I think, it's reasonable for them to ask. Okay, so 6 and 9 are honestly the hardest parts for me to explain. But question 10 is very easy. It's an indices question. So if you're very strong in ISL, you have no problem for sure. Question 10. Find the values of x and y which satisfy these equations. This is 10 part A, sorry. There's a part B later which involves surds. 3 to the power of x plus y equals to cube root 27, and 4y minus over 2x is equal to half the power of negative 3. Okay, so these are your simultaneous equations. So what do we know? So cube root 27 is just 3, right? So this is 3 to the power of 1. So we know x plus y equals to 1 from the first equation. And then 4 over y minus 2 over x, no, 4 to the power of y over 2 to the power of x. This is 2 to the power of 2y. So we can say that this is 2y minus x, right? So 2y minus x, then this half is 2 to the power of negative 1, so this is 2 to the power of 3, right? So this will be equal to 3, correct? So now we make y the subject, y equals to 1 minus x. Then we have 2 minus 2x minus x is equal to 3. This is 2 minus 3x, of course. So x will be equal to, so there's 2 minus 3x, right? So x is obviously just going to be negative 1/3. From here we can see that y is equal to 4/3. I'll move this up here. This is what you need to look at in the final answer. Okay, that's 4 marks. Part B is surds. Question 10, part B. I'm just doing this roughly here. Part B, a circular cylinder of volume 3 square root 7 minus 6 pi. I'll write this as this. Cm cube has a height of 2 plus square root 7 cm. So, and a radius of rcm. Okay? Without using calculator, obtain an expression for r square in the form a plus b square root 7, where a and b are integers. Okay, so we need to find this, right? So what do we know? So we know that the formula for volume of cylinder is pi r squared h. The pi we can get rid of, so we just need to do the r squared h, which means that r squared will be equal to 3 square root 7 minus 6 over 2 plus square root of 7, correct? I will work this out over here. So this is equal to, so we'll use conjugate surds, multiply this by 2 minus square root 7 over 2 minus square root 7. Then you will see that this is this become a, yeah, this becomes 7, then that becomes 4, so that becomes a negative 3. So this become minus over 3, then let's multiply that. 3 square root 7 minus 6, 2 minus square root 7. Okay, let's expand this. This is equal to 6 square root 7. Then minus 21. Minus 6 times 2. So this is minus 12. Then minus 6 minus square root 7 plus 6 square root 7 all over 3. Yeah, don't forget about the minus. Okay, so this equals to minus. So let's just say, good, minus. Okay, we can actually just cancel everything out because everything here divides by 3. So we will have the answer, just like, we'll have the answer real soon. So let's just work this out first. So 12 square root 7 minus 33. So divide that, you will just get minus 4 square root 7 minus 11. And of course, when you have this minus, you can invert this, and this will become 11 minus 4 square root 7. And that is our answer for r squared. I hope you guys are coping well. We are almost done with the paper. Only 2 more questions to go. And these 2 questions are pretty easy, in my opinion. 11 is the newest chapter that we are learning, kinematics. I will be done with this in 10 minutes or so. A dot on a computer screen moves in a straight line such that t seconds after leaving a fixed point O, its displacement SCM from O is modeled by S is equal to t cubed minus 6t squared plus 9t. Okay. Find the values of t at which the dot is instantaneously at rest. So v is equal to ds dt. So when we want to find it instantaneously at rest, v must be equal to 0. So let's differentiate this. This is 3t squared minus 12t plus 9, correct? Okay. Now we need to solve this equation. So let's say t squared minus 4 plus 3, 4x plus 3, why x? 4t plus 3 equals to 0. So let's let this be equal to 0. So let v equal to 0. Then you have t squared minus 4t plus 3 is equal to 0. You can factorize this. You will get t minus 1, t minus 3 equals to 0. So t equals to 1 or t equals to 3. There you go. So that's the first part. That's 3 marks. You should get that. Find the acceleration of the dot when it first comes to instantaneous rest. So first comes to instantaneous rest means that we will only consider t equals to 1. So we will find A. So we know that v is equal to 3t squared minus 12t plus 9. So A is equal to dv dt, and this is just 6t minus 12, right? Because the 9 becomes 0. So now we have t equals to 1. When t equals to 1, then A is equal to minus 6 cm per second squared. That one is easy, 2 marks. 2 marks because it's easy like that. I hope you guys can see this. Even if you can't, I am pretty sure you should get these marks. Okay, to the third part. Explain clearly why the total distance travelled by the dot in the interval t is equal to 0 to t is equal to 4 is not obtained by finding the value of s when t is equal to 4. Well, just as we have seen, there are turning points for this curve, and we know that it is a cubic function, so we can expect to see something like this, which means that basically what happens is that this goes in the positive direction, this goes in the negative direction, which means that we find t equals to 4, we will find the straight line distance rather than the actual total distance, and that's not what we want. So we must find the total distance. So by using t equals to 4 only, we will get the displacement. Which is the straight line distance from O to t equals to 4. Okay, and that's not what we want. We want, because we haven't taken into account, this does not take into account the reverse of direction. From the turning points, right? So t equals to 1 to t equals to 3. So because of the change of direction due to the turning points, this will result in the displacement being different from the distance. That is the explanation. It's only 2 marks. So if you don't get it, I don't say it's a big issue, because you should be able to do part after that, which is to find the actual total distance travelled by the dot from that same interval, t equals to 0 to 4. Okay? So let's consider the values. Let's consider s at those values. So when t is equal to 0, so remember that s is equal to t cubed plus, right? No, sorry, minus 6t squared plus 9. So remember that when t is equal to 0, this plus 9t. So s is equal to, so s is just equal to 0, right? Because everything here is 0. So when t equals to 1, remember that this is a turning point. So this is the turning point. So let's say that s is equal to So we will figure this out ourselves. So it's just 1, so it's quite simple. 1 minus 6 plus 9, which is 4. So s equals to 4, t equals to 3. We need to work this out. So if we multiply this will be 27, this will be 54, this will also be 27. So s equals to 0. At t equals to 4, this is 64, this is 96, minus 96, so negative 32 so far, plus 9 times 4, 36. So s is also equal to 4. Okay? So the distance, what you see here is that from here you have the distance will be 4 cm. Then from here it decreases again, but this displacement, distance is 4 cm. Then here the distance again is 4 cm. So total distance is 12 cm. Fun fact, the TYS that you guys have wrote this wrongly as 12 meters, when the whole time the question uses the centimeter as a unit. So this is the total distance. The displacement is only 4 centimeters, because what happens is that this is actually negative. Displacement can be negative, distance cannot. So what we must actually do is that we must consider the positive value for everything. That's how we find distance. And there's no offset from the origin or anything like that. It just says that it starts from the point O at t equals to 0, which means that there's no extra thing that we need to add besides all these. Okay, last question, and probably a very easy question. It is given that the function fx is equal to 2 sine 2x and gx is equal to 3 cosine x over 2 minus 1. The first question is state the least and greatest values of fx. This is easy. You should know this. Sorry, least of fx, this is just equal to positive 2, and greatest is, sorry, this is negative 2 and this is positive 2. So lowest is negative 2, greatest is 2. This is from the fact that this the sine function itself ranges from negative 1 to 1, and the lowest will therefore be 2 times of negative 1, greatest will be 2 times of 1. Okay, that's easy. That's part 1. Least of gx, what is this equal to? Remember, the angle doesn't matter here. The function will still run in such a way that the maximum is 1, minimum negative 1. So the least will be negative 3, negative 1. So this will be minus 4. Greatest of the function will be equal to, remember that this maximum has 3 minus 1, so this will be 2. Okay, so that is simple. That is parts 1 and 2, those are 3 marks total. fx, stating least and greatest values of fx is 1 mark, gx is 2. Okay, last question already. State the period of fx. You can do this. The period of fx is 180 degrees. Period of fx is equal to 180 degrees. Why? Because remember that a normal function has the graph has a period of 360 degrees. And fx was 2 sine 2x. So 2x means that the period is 360 degrees without a 2, 180 degrees. Period gx is the next part. N is x over 2. So the period is times 2, 720 degrees. So you should get the first 5 marks pretty easily. Now we need to do a sketch. On the same axis, the graphs of y equals to fx and y equals to gx for 0 is less than x less than 360. So let's draw it like this. This is x, this is y. This is 0. Let's let this be, okay, let's say this is 90 degrees, 180 degrees, 270 degrees. I'll extend this just a little bit. 360 degrees. Okay? So remember that fx, just a reminder that fx equals to 2 sine 2x and gx equals to 3 cosine x over 2 minus 1. Okay? Just a reminder what fx and gx actually are. Okay, so y equals to fx. So we know that the highest point will be 2, so let's draw a 2 here, and the lowest point will be a negative 2. I'll need to extend this line, you'll see why later. Okay, so we will know that it starts from 0, and because it's 2x, remember that for a normal graph it will look something like this. but it's 2x, so it will go up and then go down. At 90 degrees, it will be 0 again. So let me trace it. So I think I'll redraw this part, but the curve looks roughly like that. Okay, just bear with me. So remember that this will peak again at 2, and then we will come back down again. It will come to 0 here, then it will come here, and then back up. So this is y equals to fx. Okay, y equals to fx over here. Then gx is 3 cosine x over 2 minus 1. Now remember that when we start here, when we start with cosine, we will always start from the maximum value. So this will be 3 minus 1, 2. So it will start here. But when you have cosine, it will go something like this normally. It will go like this, and then it will go like this, then like that. But this is a half, so it will slow down. So it will come here and like that. What happens is that when this is 90 degrees, this thing will be 45 degrees. So it will still be somewhere here. But when this is 180 degrees, this will be 90 degrees. Cosine 90 degrees is 0. So let's just draw this here. Now what actually happens is that this will actually go underneath and this will be at minus 1, because what happens is, you remember you have a minus 1 here. So this, although this is 3 cosine x over 2, when x equals 180 degrees, this is 0, minus 1, so negative 1. Then continue going and it will reach this point. This is the minimum point, this will be negative 4. Okay, so this is y equals to gx. Okay? Finally, the very last question. State the number of solutions for the equation 2 sine 2x plus 1 equals to 3 cosine x minus x over 2 for 0 degrees is less than x is less than 360 degrees. Okay, this is very easy. Remember, these are our equations. So what actually happens is that the equation here given in this question is literally just plus 1 from all these. So this is plus 1, this is plus 1, but that means that this just means that the c value of all these functions just goes up by 1, but that does not change the solutions. That does not change the number of solutions. So we just need to see how many times it cuts the curves intersect. So 1, 2, 3. So the final answer for part C is that there are 3 solutions. Okay, that's it. That is 2019 GCE O-Level Additional Mathematics Paper 1. I'm quite tired right now, but we are done. I know there's been some rough bumps along the way, but if you have any questions about this paper, if you're one of my classmates and you're watching this, you can message me later on. I'll be exporting this to YouTube so you guys can watch it as well. As for the rest of you, if you're watching this because you're bored, well, thank you for coming along. I'm not sure when I will do the paper 2, hopefully soon enough. For now, I'm just gonna go and eat lunch because I actually haven't. Okay, thanks guys.